In this session, we're going to be reviewing the 3D Polyline utilities that are specifically included with Carlson Civil. We're running Carlson 2012 with the IntelliCAD CAD engine and have the Civil module loaded. The 3D Polyline utilities are found on the 3D data menu, about 2/3 of the way down where it says 3D Polyline utilities. Several of these are included with Carlson on the Edit menu under 3D Polyline Utilities, specifically Offset 3D Polyline, Fillet 3D Polyline, Join 3D Polyline, and Add Points at Elevation. Those four commands are covered in a separate video called Polyline 3D Polyline Utilities, and you can view that to see how those tools operate. So we're going to look at the ones that are specific to just Civil. First one is Merge Crossing 3D Polylines. In the drawing, I have a number of 3D polylines, and you can see that this white one is crossing here. So we're going to pick a main polyline. That's the one that we want elevations to match. And then we're going to pick what we refer to as a side polyline. The transitional PVI distance is a distance for a flat zone. We're going to add a vertex in the white polyline to match the green one, and this would give us a flat distance on either side. And then we could have a transitional vertical curve length. So if these were profiles represented under center lines, we could actually add vertical curves and even specify information for the main road, the green line, its roadway crown, the offsets on either side, and the slope to use. In this case, we're not going to use those. We'll simply watch it update the polyline. So now if I look at my polyline, I have a vertex here. It's at elevation 188.2. And if I look at the other polyline, at that point, it's also at 188.2. So we took the white polyline, which was connected simply here and here, and have moved it over. So if we view this with our 3D viewer window, what we should see is a polyline that has a simple V in it. So that's how we can merge those lines and eliminate crossing break line errors in a triangulation routine. Next, we'll go back and look at another one of the utilities that are unique to Carlson Civil. Snap contours to 3D polylines. To do this, we need to have contours, so I'll go ahead and turn those on. And I have a polyline over here. What this does is it forces the contours to snap to a polyline. Generally, this would be used to clean up some of your contours, make them match your break lines more closely. For reasons of visual dramatization, we'll actually be moving this contour to snap to that polyline. You can select your contour layers from a list, or you can go graphically pick them and get them added here. You can remove other layers you don't need, and the same is true for your reference layer. So these are the contours that are going to be snapped to the 3D polyline on the reference layer. You have a maximum snap distance, a Z tolerance. What this is saying is if the vertical difference is less than this amount, then don't move the polyline. And then a transitional distance. And I'm using fairly large numbers so I can make my arbitrary situation work here. Asks us to select the polylines to process. So we'll just cross those and watch this polyline in particular. And you can see how it was forced to snap to this line. It processed 15 contour polylines and adjusted only this one. So the rest of these were within tolerance, or we didn't have enough slack to move them where they needed to go. So that's how you can use the contour snap. I'm going to go ahead and undo that to get those put back. And we'll go back to our 3D Polyline utilities, and we want to look at 3D Polyline by slope on a surface. We specify a layer that this line is going to be on, a tin that it's going to follow, and then a limiting length. So if there's a maximum length that you want to use for your polyline, you can specify that. In this case, we won't have one. What we're going to do is pick a point. We'll turn our object snap off here. We're going to pick a point and then tell it to draw a polyline going up the surface. You can go up or down. And which side is going to be facing downhill. In this case, I want to go up and to the right, so downhill will be on the left, as is the default. And then I can specify what slope I want to go up the hill. This routine will find the slope that I'm looking for. So we're going to do a percent, and I'm going to try 5%. And you can see, well, in the command here, and then I'm going to freeze off the intermediate contours so you can see our line better. This line tracing up the hill at a 5% slope until it found an area that was flatter than 5%. So I now have a route up the hill. I can use this to overlay a center line on, design a road to get me from the bottom to the top of the hill without exceeding a design slope. Okay, that's a wonderful little utility, helpful for designing things like haul roads and access roads. Next, we're going to look at the minimum maximum slopes for 3D polylines. What we're looking at here is whether it's sloping uphill or downhill, positive or negative slope. What's the minimum slope that you want to allow? So if you want it to never be flat, we can say a minimum of 1% slope, and we never want to go over 10% slope. Not something I would typically do with existing ground brake lines, but something that you might do with design to keep it within design parameters. When we select all of our brake lines, it went in and it changed 61 brake lines to ensure that none of them have slopes outside of the specified range. So you can see why this is not something you would typically do with existing ground information, but more so with design information. I'm going to go ahead and freeze off these other contours here so we get back to just our brake lines and go back and look at a couple of these other ones. Follow tin edges allows you to create a perimeter that follows the tin lines exactly. Put them on a layer called perimeter using our existing ground tin again. You simply draw a boundary where you want this, and then it adds, in this case, the blue line, which is following the triangles as it looks at this perimeter. So it's never going to match exactly, but it gives you a perimeter that follows the triangle edges. Next, we can extend polylines to an elevation. So if we look at this 3D polyline, this point is at elevation 210. This point is at 215, so it's sloping downhill. So what we'll do is look at extending this polyline to an elevation, and notice it tells me the endpoint elevation is at 210.595. Well, let's extend it all the way down, the rest of the way down to 210. The slope to extend, 5%. That's the slope of the line. And so the endpoint now is at elevation 210, as you can see down at the bottom. Going back, we're down to our final command here. Well, actually, yes, we are down to our final command here. Break 3D polyline by surface. Source of the surface file or surface data will be a file. entities, polylines to clip. We're going to clip this one. And again, we'll pick our existing ground tin. Erase polylines below the surface. Yes. And you can see how it deleted this section of the polyline and our extension of the polyline, both of which fell below the surface. So it has added vertices in there on a fairly tight interval so it could eliminate those pieces that were below our surface. So this is a way to eliminate that data that is below the surface and see just those things that are above. So quickly here, as we're getting a little long on this particular video, the tools that are unique here in 3D data in Civil are merging crossing 3D polylines, snapping contours to 3D polylines, creating 3D polylines by a slope on a surface, setting minimum maximum slopes for 3D polylines, following tin edges, extending polylines to a specified elevation, and breaking 3D polylines by a surface. Again, if you have more questions about 3D polyline utilities, be sure to watch the other video entitled simply 3D Polyline Utilities.